I'm Siddharth Kaul and I welcome you to Edupedia World. This is a part 2 video of unit testing where I'm talking about how to create and work with unit tests in your Matlab program and code. The video has been divided into 9 sections. The first one covers the qualifiers that are there in the class-based unit test. The second section deals with grouping the tests using the tags. After that, I discuss about shared fixtures, custom fixtures, and parameterized test. The last two sections deals with creating test suites and running tests for various workflows. First, I will start with types of qualifications. These are the functions that test the values and respond to failures. As I have discussed in the previous video, there are 4 types of qualifiers. First is verification that produces and records failures without throwing an exception. This means that the remaining test will run to completion. Then there are assumptions. These ensure that a test runs only when certain preconditions are satisfied and the event should not produce a test failure. So when an assumption failure occurs, the testing framework marks the test as filtered. Then there are assertions. These ensure that the preconditions of the current test are met. If not, then these assertions fail. Then we have fatal assertion. This is similar to the assertion with the difference that these are used when failures at an assertion basically renders the remaining portion of the test invalid. The table is divided into 4 columns. First column is type of test, and then the equivalent methods are covered in the verification, assumption, assertion, and fatal assertion. I will just quickly browse through these tables. So we have a type of test as value is true. So for verification, we have verify true, assume true, assert true, fatal assert true. Then second, similarly, we have for value is false. So if the value is false, it will return as pass. And if it is not, then it will return a failure. Then we have value is equal to the specified value. Here we can compare with the given value, with the user provided value and get a pass or failure based on that. Then there are two values are handles to the same instance. So when we need to find out whether the two handles point to the same data, we use these qualification. Then we have values not handled to specified instance. So this is also something similar to having the same handle, but this is the not case of that. Then we have function returns true when evaluated. So if the function returns true when it is evaluated, then the test is passed, otherwise it is not. Continuing, we have tests that produce unconditional failure. These are verified by methods like verify fail, assume fail, assert fail, and fatal assert fail. Then we have value that meets a given constant. So these constant can be a logical constant or a numeric constant or a constant constant. Then we have a type of test where value is greater than or equal to the specified value. If this case is true, then it is pass. If it is not, then it returns as fail. Then we have value is less than the specified value. When this scenario happens, then it is a pass case, otherwise it is a fail case. Then we have value is less than or equal to the specified value. Here we can have a user provided value and we can have a qualification whether it is less than or equal to the specified value. Continuing with the table, we have also the type of test where we can get the type of the object that is there. Whether the number that we have is of data type double, integer, something else, or it is based on a structure. So we can test that as well. Then we can also test for emptiness. If a value is empty, we can pass it as true and we can pass it as fail. Then we can also check for not empty. If value is not empty, then it is pass. If it is empty, then it is fail. Then value has specified size. Also we can have a test for the size of the value. So this size can be in bytes, in the data type, or in some other format. Then also we have value that has specified length. So if the length of that value is something that we want, we can constrain that in using this type of test as well. Then value has specified element count. This is for finding out the number of elements in a numeric array. If they have these many number of elements, then we pass the test, otherwise we fail the test. Continuing to the last leg of the table, we have a type of test where we can compare the string. We can test for the string that contains specified string. Then again we have string that matches specified regular expression. Then we have function that throws specified exception. We can also, this is one of the cool things, where if certain exceptions are thrown by a certain function, we can verify that, okay, this error is coming, hence this test has passed. With this error is not coming, hence this test has failed. Also we have function issues that specified warning. Based on the warning that a function generates, we can have our test case. If suppose a function generates a warning X and we know that this X warning is supposed to come. So if this comes, then the function has passed, otherwise it has failed. Then we have function that issues no warning. If there are no warnings coming from the function, then our test has passed. If some warning is coming, then the test has failed. So these are the methods, total 25 methods that are there for these types of qualifications. In this second section, I will talk about how to use test tags to group tests into categories and then run the test with these specified tags. So here example tag test that is inherited from the test case class. So this what you see here is an untagged test. So basically test A is not tagged to anything and this class is also not tagged to anything. So how can we start tagging functions in a class? So to tag a function, we use a cell array of meaningful strings. For example, here in this method block, I'm tagging function test B and test C. So I'm using test tags and I'm adding a meaningful group that is unit. So basically whenever the test is called based on tag unit, these two test case, that is test B and test C, will execute. Similarly, we can tag multiple groups. Like here in this method block, test D is tagged under both unit and feature A. Similarly, here test E is tagged under both system and feature A. This is what tagging of a method looks like. Now let us look what does tagging of a class look like. So I will open this another file. This is a example tag class test. This is again inherited from the test case, but the difference here is I am grouping it under feature B. So what this means is all the methods under this example tag class test will be grouped under feature B. So here you can see there is a method block under which there is function testf. This is not tagged into anything. So but this will automatically be tagged under feature B. Now what we can do is we can create additional tags for the methods available in the class. So here in this example, there is a function testg where we have tagged him in the feature B as well as in feature C and the group system. Similarly, test H is tagged not only under feature B but also under system and feature A. Now let us see how we can run this test. So again, I'm going to run this test using the run test method. So I'm going to call run tests. I'm going to use a cell array. I'm going to write this example tag test and I'm going to write this example tag class test. Now I'm going to tag it like call the tag function and I'm going to say, for example, feature A. I'm going to hit enter. There's a spelling mistake. It is run tests. So it has to be S. There has been to be run test with an S. So I'm going to go to the end and I'm going to click enter. So it will run all the tests that are tagged in the feature A. So you can see only 3 tests were executed and we can get the tabular format something like this. So you can see 3 tests were executed that were tagged under feature A, that is test E, test D and test H. So this is the way you can tag methods and classes under tags and you can call them using run test method. In this section, I am going to show certain examples that demonstrates how to use shared fixtures when creating tests. Test fixtures can be shared across test classes using the shared test fixtures. These are the attribute of test case class. To exemplify this attribute, I am going to create multiple test classes in a subdirectory of my current working folder. But here the test methods will only be shown at a high level. The 2 test classes that I am going to demonstrate here are doc polynomial class and the bank account class. Both classes can be accessed in Matlab, but it must be added to the Matlab path. A path fixture adds the directory to the current path, runs the test and removes the directory from the path. As here both the classes require the same addition to the path, so here the test will be used as a shared fixture. Here I will demonstrate you how to write test cases using a shared fixture. But first, let me show you two test classes. First is the doc polynomial test class. So basically, here my shared fixture is some example in the examples root folder where there is a doc polynomial class. So my class, that is doc polynomial test class, tests that class. So I have inherited the class from the test case, and this is how my class looks like. So I have a function test constructor, test addition, test multiplication, and so on. So basically the point here is I have used the shared fixtures like this, where I have associated the path to the example. Now let me take you to my second class, that is a bank account test. So again, this also tests a class, that is bank account class, that is located at the same example folder. So here also I am using a shared fixture like this, that is a path fixture that has been shared among both. And bank account test is then inherit from the test case class. So again, it also has tests like test constructor not enough inputs, test deposit, test withdraw, test notify insufficient funds, and so on. So now I'm going to show you how this actually works. So let us run these two test cases. So I'm going to write results, and using the run test methods, I'm going to execute both of these. So I'm going to execute doc polynom test and bank account test. So now I'm going to execute this. So as you can see, so let it work. So I will take you down to the start. So as you can see, there is a setup for the path fixture, and after that it says it has done setup for the path fixture and the path has been added. Now it starts running the it executes the doc polynomial test. After that it starts running the bank account test. So there are some failure in that, and there are some undefined stuff, and there are some errors that has been thrown, and in the end all the test has been done. Now this is how a shared fixture is done, that in the initial case for both the classes, as they were using the same path, we use the same path shared fixture. Again, you can get the summary out of it by using the table results, and you will see all the tests that has been executed. So in the doc polynomial test, these 3 test cases were executed, and in the bank account test, these 5 test cases were executed. So this is how a shared fixture is used among multiple classes. Moving on to the 4th section, I am going to demonstrate how to create a basic custom fixture. The example I am going to show where I have implemented a basic custom fixture that will change the display format to hexadecimal representation. After the testing is complete, it will restore this display back to its pre-test state. First step is I am going to create a format hex fixture class definition. So in a file in my working folder, I have created a new class, format hex fixture, that inherits from Matlab unit test fixtures fixture class. Since we want the fixture to restore the pre-test state of the Matlab display format, I have created an original format property to keep track of the original display format. Next, I have implemented a setup and teardown methods. All of the subclass of the fixture class must implement the setup method. I am going to use this setup method to record the pre-test display format and set the format to hex. I am going to use the teardown method to restore the original display format. These setup and teardown methods are created inside the methods block of the format hex fixture.m file. Format hex fixture that we are going to apply to our test class. So as seen before, this format hex fixture changes the display format to hex display, and then after the thing is done, it restores the display format back to the original format. So we have this properties original format, where we get the format and store it, and then we set the format to hex, and in the teardown function we set the format back again to the original format. Now let us take a look at our class-based test file, that is the sample test. So in this sample test, basically that is the inheritance of test case, we have a function test1. Here in the test case object, we apply the fixture of this format hex fixture. So this is how any custom fixture is applied. You use the test case object provided by the unit test framework, and you use the method apply fixture and then pass your function format text fixture to it. So here the display will now move to a hex based display. After a test has completed execution, then the display will be restored back to its normal original format. So now let us run this test. So I'm simply going to just run this sample test. So the test has been run. If this does not suffice, we can use the similar run tests method. And run test method, and I'm going to pass this sample test class. So as you can see, it has run its test and it has executed. We can get the result out in a table, something like this. So it executed one test, test1, and it failed. Basically it is incomplete and it has failed. So this is how you can apply a custom fixture to or any of the class-based test. Moving on to the fifth section, I am going to talk about some of the advanced fixtures you can do in the custom fixtures. Apart from path, directory and display format, you can control the environment the test runs in. Let me show you with an example. Apart from display changes and path setting, there are many things that can be done using a custom fixture. So one of the things that I'm going to show you is like how to set an environment variable prior to testing, and then how you can pass that variable through all your test methods. So what I'm going to do is I'm going to store this username variable and I'm going to pass it across multiple tests. So here I have created a custom fixture that is username environment variable fixture that is nothing but inheritance from Fixture class. So here I'm going to set the property that is username that is to be passed between the methods. Now first let me make a constructor for this fixture. So this is a constructor for fixture, this username environment variable fixture. So this validates the input and defines the setup description. So this constructor can accept a string and set up the fixture's username property. So whatever the setup username property has to be set, this can be set through this constructor. Then there is a setup. So every subclass of fixture must implement a setup method. That is the rule, because apart from that it will not know what the setup will have to do. So setup method has to be implemented for every class that has been inherited from this fixture. So this method here in this case it also defines the teardown function. So here I have added the teardown function that will reset the username back to the original username. Other than that, I have this is compatible property. As all the classes that are derived from the fixture must also implement the is compatible method. This is implemented because we have a configurable constructor. So whenever we have a configurable constructor, this is very recommended that the is compatible method is defined. Since here in this case we can configure the username property to the constructor, so we need to implement the is compatible method. So what is compatible method does is it compares the fixture username with the other username and see whether the two instances are compatible or not. If they are not compatible, then it will not accept the username. Now how to use this fixture? Again, I will start with example test. Here I have defined an example that is an inheritant from the test case. Here using the test case object and the method apply fixture, I am applying this custom user defined fixture. So this is how you can define fixtures for a certain class. Now let us run this. So I'm going to run this and I'm going to pass this example test. So it will run this test and it will see that a test has been executed using this fixture. So the current username is David and it is done with the example, then it has again restored back the original username. Now, one of the cool things about this custom fixture is that you can use it as a shared fixtures among classes. So here I have three classes, that is test A class, test B class and test C class. So what I'm going to do is I'm going to use the same fixture across all these classes as a shared test fixture. So again in the test A definition itself, I have used a shared test fixture and I have passed this username environment variable fixture with the username to it. So this becomes a shared fixture for test A. Similarly, I have done for test B and similarly I have done for test C. Now we can run all these three tests, and these three tests will share this fixture among them. So I'm going to results, run tests. I have test A, then I have test B, and I have test C. Yes, there is a mistake here. I have to group them together using a cell array and like this. So all the three test cases have compiled and run and executed using this shared test fixture. So this is how you can use custom test fixture to both use as a applying fixture to classes and as a shared test fixture among classes like test A, test B, and test C. In this sixth section, I will talk about how to create a parameterized test. I'm going to give a demo about basic parameterized testing by using an Sierpinski function. So this is my function that I'm going to test. So this function returns a matrix that represents an image of a Sierpinski carpet fractal. So basically it takes the fractal level and an optional data type. The function looks something like this. Now to test this function, I have a class that is test carpet class that will test this function. So basically this is a class that has been inherited from the test case. So this will test my Sierpinski function. So in the properties method under test parameter, I'm going to define the properties that are going to be parameterized. So I have a type property, a level property, and a side property. The type property contains the different data types that I want to test. The level property contains the different fractal level that I want to test. The side property contains the number of rows and columns in the Sierpinski carpet matrix, and it corresponds to the level property. So to provide more meaningful name to each of them, I put them in structures. Now under the method of test, I'm going to define the test cases for this. So the first function is the test remain fixes. So it takes the test case object as well as a level object for an input. So this method tests the output of Sierpinski function by verifying that the number of non-zero pixel is same as expected for a particular level. So this method uses a level property and therefore results in three test elements, one for each value in the level. Second test case that I have is the test class. This test class method tests the class of the output from the Sierpinski function with each combination of the type and level properties. This kind of function takes in the type and the level and results in 9 different test elements. Then I have a test default L1 output. This test method does not use a test parameter property, and this is not a parameterized test. So this will verify that the level 1 matrix contains the expected value. As this test method is not parameterized, it results in only one test element. So in the test methods above, you might have seen that I have not defined parameter combination attribute of the test methods block. This attribute is by default exhaustive. So the test framework invokes a given test method once for every combination of the test parameters. So I have defined another methods, that is the test parameter combination sequential. So in this we have test number L, number 1, that takes in the level and the side, and it sequentially invokes once for each corresponding value of the parameters. The properties level and side must have the same number of values. Since these properties each have 3 values, the test number 1 method is invoked 3 times. So this is how it looks. Now let me create a suit out of this test case. So I'm going to create a suit and I'm going to refer to the Matlab unit test suit library, and from file, and I'm going to pass this file, that is the test carpet.m. So from this file I'm going to create a suit. So now let us see how many test cases are created. So I'm going to refer to the name property and let's see. So here you can see total of 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. 16 test elements have been created. So these are the parameterization. So test number 1 first goes with level small and side small, then goes with level medium, level large, and side large. So instead of defining these three test cases, we're using just one test case and parameterized value. We have created three different test elements. Similarly, for test remains pixel, for three different levels, this test case will be executed. So we have level equal to small, level equal to medium, and level equal to large. Similarly, test class have 9 elements, that is single small, single medium, single large, then double small, double medium, double large, then unsigned integer small, unsigned integer medium, and unsigned integer large. And last, as this test case was not parameterized, so it is only calls once. So this is how a parameterized test works. Now we can just run the complete suite by suite dot run, and it will execute all these 16 test cases. It's going to take some time as because of 16 number of test cases. So as you can see, the progress is shown here. Sorry for this delay. So as you can see, 16 test cases were run, where all the 16 passed, and the total time taken was 46.9651 seconds. So this is how a parameterized test looks like, and this is how a parameterized test works. In this 7th section, I will build upon the basic parameterized test just I demonstrated in the previous section. So I'm going to build upon that. You already have seen how a parameterized test works. Here in this section, I will show how to create a test that is parameterized in the test class setup, test method setup, and the test methods block. Here I'm going to test the random number generator. First, I will give you a little theory before diving into the code of the test. The test random class that I'm going to create is parameterized at 3 different levels. First is the test level. To define methods under this level, you can write the function under the methods block of test. To define properties for use at this level, you have to define property under the test parameter attribute. Similarly, there is a method level setup. Where to define functions for this level, you need to write them under the method block of test method setup. Then to define properties for this level, you need to write them under the method setup parameter. Then there is a class setup level. Where to define function for this level, you need to write them under the method of test class setup, and parameters for the same can be written under the properties attribute. There are total 3 parameter combination method attributes that are there for test parameterization. Exhaustive, first is the exhaustive, that is the default attribute. That means methods are invoked for all combination of parameters. The test framework uses this default combination if you do not specify the parameter combination attribute. Then there is a sequential attribute. Here the methods are invoked with the corresponding values from each parameter. Each parameter must contain the same number of values. Then there is a pairwise attribute. Here the methods are invoked for every pair of parameter values at least once. So here in the test random test class, all of these 3 attributes are being used. Now let me show you the code for the test random class. So here is my class for test random function that is inherited from the test case. So here I have 3 properties methods. One is property methods for class setup parameter. This parameter will be used to set up the class. Here I have used generator with 3 combination, that is twister, combination recursive, and multi Fibonacci. Then second method block is properties method setup parameter. These parameter will be used at method level. So here seed has 3 values, that is 0, 123, and this huge number. Then this is the third method block, that is the test parameter that will be used at the test level. So here I have 4 parameters, that is dimension 1, dimension 2, dimension 3, and the type, whether it will be single or double. So to make it more readable, I have made these 3 dimensions as structure with the sizes of small, medium, and large. Now let's move on to the methods block. So first I have a test class setup method. So under the method blocks in the test class setup method, I'm going to define a class level setup method. So this is the method that will register the initial random number generator state. So after the framework runs the test, the method will restore the original state. So the class level setup defines the random number generator, and the test method setup defines the seeds for the generator. So here in the class level method block, I have this class setup, and under the test method setup block, I have a method setup. Now moving on to methods for parameter combination. So first is the sequential. So this method will test the size of the output for each of the corresponding parameter in dimension 1, dimension 2 and dimension 3. Similarly, I have another parameter combination pairwise. So this framework will invoke these methods at least once for every pair of the property value. Now, I have also created a default parameter block like methods test with no parameter at combination attribute set. So this will become an exhaustive kind of attribute. So this test framework invokes these methods once for every combination of these three property values, that is dimension 1, dimension 2 and type. Now let me create a suit for the same. So I'm going to create a suit. I'm going to invoke the Matlab unit test suit library, and from file, this test random file, I'm going to create my test suit. So my test suit is created. You can see there are 279 elements to it. So basically just by writing 3 or 4 functions, we are able to generate 279 elements. This is the beauty of parameterized test. By using very few things, you can test a huge number of combinations. So right now I'm not going to run this test as it's going to take a long time, but you get a good idea about it. So this is how a basic parameterized test is converted to advanced parameterized test, where from starting with 16 test elements, we have now close to 280 test elements in a single class file.
In this 8th section, I will talk about how to combine tests into test suites. I am going to take the example of solver test case. So let's start then. You have seen this in previous video, but here I am just summarizing the ways in which test suite can be created. I will again visit the quadratic solver function. It is the same function you have seen in the previous video. This function takes in the input a, b and c that are the coefficient of the equation of form ax square plus bx plus c is equal to 0. The function will first check whether the coefficient passed are numeric or not. If they are not numeric, it will throw an error and exit out. This function will return the roots in an array of size 2 from the variable roots, which will contain both the roots of the equation. I will use the same test class file solver test where I have 2 test cases, one for the real solution and one with the imaginary solution. In the real solution, I pass the coefficient for the equation x square minus 3x plus 2 equal to 0. So the coefficient turns out to be 1, minus 3 and 2. The expected solution for this is 2 and 1, and I am going to compare the actual solution with the expected solution using the qualifier verify equal, which will fail the case if they do not match. In the imaginary solution, I pass the coefficient for the equation x square plus 2x plus 10 equal to 0. So the coefficient turns out to be 1, 2 and 10. The expected solution is minus 1 plus 3i and minus 1 minus 3i. I am going to compare the actual solution with the expected solution using the qualifier verify equal, which will fail the case if they do not match. Now let's start with creating the test suite. Before creating the test suite, there is a need to import the test suite class from the current import list. After importing the test suite class, you can create the suite from the solver test class. Here you can use the from class method and pass the solver test class, and then using the run method you can run the suite class. The second way is you can create the suite from the class definition file. Here using the from file method and passing the class file you can create the suite file. Then using the run method you can run the tests. Third way is you can create the suite from the single test method. Here using the from method and passing the class and function name, you can create test suite with only some particular test cases. In this 9th section, I am going to explore and summarize various ways tests can be run. First is running all tests in a class or function. Here using the run method of test case class, you can directly run tests contained in a single test file. When tests are being run directly, there is no need to explicitly create a test array. As seen in the code snippet here, the first line directly runs a single class-based test in .polynomial test file. The second line shows how to run a single file of function-based tests. The next snippet is where I have created test case objects for each of the class and the function. Now using these test case objects in this functional form, I am running the tests. Another way of running these functional form is using the dot notation, like T1 referring to class-based text polynomial test, and I am running it by calling run function from it in form T1.run. Similarly, for function-based test access properties test, I have a function form of T2 and I am running it using dot notation in form T2.run. Second kind of workflow is running a single test in a class or function. Single test from within a class-based test file can be run by specifying the test method as an input argument to the run method. For example, in the first line, I have ran only the test multiplication test from the polynomial test file. Here I have called the run function, passed the class name and also the individual test name that is to be executed. In case of the function-based testing, some sort of similar thing can also be done. The difference is that in the function-based testing, the function-based test files returns an array of test objects instead of a single test case object. You can run a particular test by indexing into this test array. Here the care has to be taken in a way that you must examine the name field in the test array to ensure that the correct test to be run has been selected. For example, in the access properties test, this function-based test file will return me the test array. I am going to first see the name for each of the test cases by using the name field as a dot notation. The result will show both the test name in sequence. Now I know that the surface color test is at index 2. So I'm going to index the T2 test case object to 2 and using the dot notation run, I'm going to run that particular test. So it will look something like this, T2 with indexing of 2 dot run to run that second test case, that is the surface color test. Third way of running test is running suits. Here I'm going to run a test suite by name. Here I have grouped both the classes based test, that is polynomial test, and function based test, that is access property test, into one test suite. Now using the run test method, I am running both the group of tests. I can also run all the test cases in the current folder by passing the pwd as an input to the run test function. Fourth way of running test is by creating test suites from test array. Basically, here you can explicitly create test arrays and use the run method in the test suite class to run them. Here I have created suite S1 from the class based test polynomial test and suite S2 from the function based test, that is the access property test. And then I went on to create a full test suite by concatenating them into full suite. Afterwards, I ran the complete suite by calling the run method. This explicitly defines suite, and running it has one advantage, that it becomes easier to perform further analysis on the suite. Further analysis include rerunning the failed test or isolating the past test or rerunning the past test or something like that. Here in the last snippet, I have indexed the full suite based on the result of the test, and only those tests will be selected that have failed. This will store them in failed test suite, and then I can separately call this failed test suite from the run method. One of the last ways of running the test that I'm going to discuss is using the customized test runner. This way you have the power to specialize the test running by defining a custom test runner and adding the plugins. First, I generated the test suite S1 from the class based test, that is the polynomial test, and the suite S2 from function based test, that is the access property test. I clubbed them together into a complete suite. I am using a plugin to create a silent test runner, and then again I am using another plugin to display test progress. And afterwards, I am running the suite using the run method and using this customized test runner as an input. So my run method will look like, I will pass first my customized runner, that is the runner, and then I'm going to pass the suite that I want to test. These are the various ways you can work with the tests. This concludes the part 2 video of unit testing. In the next video, I'm going to continue with the part 3 of the unit testing and we'll move forward from there. So until then, please subscribe and thanks for watching.